The topic of this tutorial is the 8 fundamental trigonometric identities. Maraming iba't ibang identities sa trigonometry, pero meron lang 8 na tinatawag na fundamental or most important and basic trigonometric identities. And these are the 8 trigonometric identities. Ang tatlo dito ay reciprocal identities. Cosecant theta equals 1 over sine theta. Secant theta equals 1 over cosine theta. And cotangent theta equals 1 over tangent theta. And their reciprocals. Dalawa dito sa 8 ay tangent theta equals sine theta over cosine theta. Cotangent theta equals cosine theta over sine theta. These two are the ratio identities. And the last 3 are the Pythagorean identities. Sine theta squared plus cosine theta squared equals 1. 1 plus tangent theta squared equals secant theta squared. And 1 plus cotangent theta squared equals cosecant theta squared. Ginagamit ang 8 fundamental trigonometric identities para mapatunayan o ma-prove kung equal ba talaga ang dalawang sides ng isang given trigonometric equation. Ang pagpo-prove ng isang identity ay iba sa pagsosolve o pag-satisfy ng isang equation. Nagkakapareho lang ito sa paggamit natin ng techniques or operations para mag-solve. At ang mga kaibahan naman ng mga ito ang ating problemahin sa pag-identify ng isang equation as an identity. To prove an identity, we have to use logical steps para ipakita na equal talaga ang dalawang sides ng isang equation. We have to work on one side only. Kahit saan sa dalawang sides, basta sa isang side lang. Mas maganda na sa more complicated side tayo mag-work para mas maikli at more definite ang ating solution. I will perform various examples later on. By the way, we can also work on both sides. Pero hindi lang natin ma-justify logically yung original given equation ng isang talagang identity. So, here's one example. Cotangent x over cosecant x equals cosine x. Since this is the more complicated side, ito yung babaguhin natin para maging cosine x, para maging identity, or para ma-prove natin that this equation is really an identity. So the process goes like this. Cotangent x over cosecant x, papalitan natin sila ng values, kung saan mag-i-equal siya sa cosecant x with the use of these 8 fundamental identities. Now for instance, yung cotangent x, among these 8, merong 3 kung saan involved yung cotangent theta. Ito, this one, cotangent theta equals 1 over tangent theta. This one, cotangent theta equals cosine theta over sine theta. At ito naman, 1 plus cotangent theta squared equals cosecant theta squared. Now, ang hinahanap natin is cosine x. So, ito yung may pinakamalapit na relationship, yung cotangent theta. Kaya ayun yung ginamit natin sa ating example. And this one naman, cosecant x. In this example, or in this 8 fundamental identities, merong dalawa na involve yung cosecant theta. This one, and this one. Now, since merong sine theta, yung ginamit natin kaninang identity, so we would probably use this one. Now, we use 1 over sine x. Now, since cotangent x is over cosecant x, yung values kanina ay i-divide natin. So, cosine x over sine x divided by 1 over sine x. And then when we divide, we reciprocal and then multiply. Cosecant x over sine x times sine x over 1. And then sine x would be cancelled out, and then cosine x now is equals to cosine x. Therefore, we conclude that the cotangent x over cosecant x equals cosine x is an identity. Now, for our next example, let us try to prove step by step. So, sa given natin, cotangent x plus tangent x is equals to secant x times cosecant x. We cannot say kung ano yung mas complicated side sa kanila. So, mamimili na lang ako and I choose the left side. Now, my first step here is to put or to convert this cotangent and tangent x's to their ratio form para maging fraction sila. Now, cotangent x, we have cosine x over sine x. So, yung tangent naman is sine x over cosine x. Ngayon, since may operation sila sa gitna, set aside muna pala natin tong kabilang side ng equation. Sa equal siya dyan. Pwede natin kuhain yung LCD niya. Pwede natin kunin yung LCD niya. So, LCD niya is sine x cosine x. Then, simplify natin or kunin natin yung numerator niya. Pag-addin natin sila. Sine x cosine x divided by sine x is cosine x. And multiplied by another cosine x is cosine squared x. At i-add ko naman siya sa quotient ng common denominator at ng denominator nito. So, ang quotient nila is sine x multiplied by another sine x, sine squared x, equals to the same. And since ngayon nakakita na ako ng isang Pythagorean identity, sa numerator cosine squared x plus sine squared x is equals to 1. So 1 over sine x cosine x. Ngayon, as I can notice, this sine x and cosine x are the reciprocals of these two. So, ngayon, pwede ko palang paghiwalayin to as 1 over sine x and or multiplied by 1 over cosine x. So, tama nga yung naging guess natin. So, ito nga yung reciprocal ng dalawa. Then, we can now conclude that these two are equal to these two. So, second x is second x cosecant x is equal to itself, second x cosecant x. So therefore this cotangent x plus tangent x equals secant x cosecant x is an identity, and our answer here is the set of our solutions. Now we are down to our last and final example. Sine theta minus cosine theta plus 1 over sine theta plus cosine theta minus 1 is equals to sine theta plus 1 over cosine theta. Mapapansin natin na wala yung right hand side sa second step. Ibig sabihin lang nun na nag-focus tayong mag-work sa left hand side at sinet aside lang muna natin yung right hand side. So itong left hand side yung napili natin na i-convert para maging katulad ng right hand side to prove this identity. Now yung process na ginawa natin, kung mapapansin natin sa second step, wala tayong kinonvert na sine, cosine, or positive and negative 1 into their corresponding equal value sa Pythagorean identity. Kasi sa Pythagorean identity, may squared yung mga values. And since wala naman squared sa mga values at both sides, kaya ang gagawin natin is i-rationalize natin yung fraction. As I said earlier, iba ang pagpo-prove sa pagpe-perform ng solution sa isang equation, pero nagkakaparehas sila sa mga techniques na ginagamit. So this is one example na paggamit ng technique sa algebra. Now, back in our algebra, we rationalize fractions with complex denominators or fractions with denominators na may radicals. Now, this is an example of a denominator that is complex. Complex yung denominator natin, so i-rationalize natin siya. Now, i-rationalize natin siya by multiplying the values of the numerator and the denominator to the conjugate of the denominator. Ang conjugate ng denominator is yung same value niya, pero iba yung sign ng middle term. Now, our middle term here is this one. Yung 1 kasi yung denominator natin na sine theta plus cosine theta minus 1 can be written in the form of may bracket, sine theta plus cosine theta, closing bracket, minus 1. Ang conjugate niya is yung naka-bracket na sine theta plus cosine theta and then plus 1. So, magkaiba yung sign ng middle term nila na 1. Negative 1 here and positive 1 here. Now, in our example, minultiply muna yung sa denominator para mas madali natin maintindihan yung process. Now, if this denominator will be multiplied to its conjugate, ito yung kalalabas ng value, sine squared theta plus 2 sine theta cosine theta plus cosine squared theta minus 1. In-arrange lang yung values, nilipat lang yung cosine squared theta or positive cosine squared theta sa tabi ng sine squared theta para ma-simplify siya. So, sine squared theta plus cosine squared theta plus 2 sine theta cosine theta minus 1. Kasi may corresponding equal value itong dalawang values na to, which is 1. Yung Pythagorean identity natin na isa. So, naging 1 na siya. And then, plus 2 sine theta cosine theta minus 1. Simplify again. Eliminate yung dalawang 1. 1 minus 1 is 0. So, ang matitira na lang is yung 2 sine theta cosine theta. Now, this is the value of the denominator of the left-hand side of our equation. Now, for the numerator, if the numerator will be multiplied by the conjugate of the denominator, ang value ay magiging 2 sine theta plus sine squared theta minus cosine squared theta plus 1. Now, since ang kailangan natin gawin dito is to eliminate the cosine, ang ginawa natin dito is yung 1, convert natin siya into its Pythagorean identity corresponding equal value, which is sine squared theta plus cosine squared theta, para ma-eliminate nga natin yung negative cosine squared theta. At so these values have to be cancelled out. Ngayon, ang value ng numerator natin is 2 sine theta plus 2 sine squared theta. Now, meron na tayong value for our left hand side. Yung numerator niya 2 sine theta plus 2 sine squared theta, at yung denominator kanina na 2 sine theta cosine theta. Now, let us work on the left hand side. Continue working on the left hand side. Since parehas yung values nito, pwede natin silang i-cancel out. Naka-cancel out na nga siya dito. So, ang natirang values na lang is 1 plus sine theta over cosine theta. Now, kung mapapansin natin yung left hand side natin na na-compute natin ay parehas na ng value sa right hand side. 1 plus sine theta over cosine theta is equals to right hand side na sine theta plus 1 over cosine theta. Now, we have proved that, or our last example na sine theta minus cosine theta plus 1 over sine theta plus cosine theta minus 1 is an identity or is really equal to sine theta plus 1 over cosine theta. So, I think that's all for now. I hope na meron tayong natutunan sa 8 fundamental trigonometric identities at sa pag-prove na rin ng identities. So, thank